Hello. This video will demonstrate how to estimate the length of a curve for a given interval. Right? Here's the procedure, and you can read through it yourself. The process is not difficult, it's time-consuming. And so with anything that's time-consuming, there are opportunities to make little mistakes. So please, please, please be patient. This will make sense as we go through our two examples. We will look at a polynomial function and a trigonometric function. You will be asked to either use 4 segments to estimate the length or 8 segments. As you can imagine, using 8 segments doubles your work. Right? But basically, you're using the distance formula. And the distance formula is not difficult. All right, so let's look at an example. Suppose we have this polynomial function 2x cubed plus x squared minus 22x plus 24. And what I would like to do is estimate the length of the curve from x equals -1 to x equals 3. That's my interval. All right, so we're going to estimate the length of this curve. And we're going to use this, we're going to do this using 4 segments. And so what we first need to do, if I want to estimate the length of the curve from -1 to 3, I need to find the length of that interval. And I'm hoping you can see from -1 to 3 that is a distance of 4. If I want to use 4 line segments, right? I'm going to take my distance of 4 and say I want to divide that by 4 segments. That basically means there's going to be a unit of 1 for each segment. All right? Okay, so I have these 5 points that are evenly spaced. Each smaller interval is 1. Right? Total distance of 4 divided by 4 segments gives me a unit of 1 for each smaller segment. Okay? So what we want to do is find out the coordinates for each point. So I need to find out what happens when x is equal to 1. All right? And I'm just going to plug this into my formula, making sure that I use brackets when I substitute a negative number. And I can see -1 cubed is -1 times 2 is -2. -1 squared is +1. -22 multiplied by -1 is +22. All right, plus 24. All right, our positives add up to 47. 47 minus 2 is 45. So one point that we know is -1, 45. Okay, now we need to do the same thing for the other 4 points. So as you can see, I've color-coded the points. And we have our 5 points for our 4 segments. And now what we want to do is use the distance formula to find the distance between our first point and our second point. This point and this point. All right? So change in x squared plus change in y squared. I want you to be very thoughtful about this. Remember, we know that the length of each smaller interval is 1. So I hope it makes sense to you that the change in x will be 1. Easily seen, right? -1, to 0, there's a distance, there's a change in 1, all right? Plus the change in y squared. 45 minus 24 is 21. 21 squared is 441, I believe. And 441 plus 1 is 442. Okay? Again, you have a calculator. You can figure this out, right? But I should check just to make sure. All right. 45 minus 24 squared. Yeah, 441 plus 1. Excellent. All right. Now, you could find the square root of this and round to 2 decimal places, but no reason to. Keep it exact. Try to be as accurate as possible. So leave it as the square root of 442. Now let's find the other 3 distances. Okay, again, for each successive distance, the change in x is 1. And we've spoken about that, right? Squared plus the change in y squared. And so now we have these 4 distances. I'm hoping you realize that what we want to do is add these smaller distances up to estimate the length of that curve. Okay, so what do we have? The square root of 442 plus the square root of 362 plus the square root of 26 plus the square root of 442 again. And what we have is an approximate length of 66.17 units. All right? So again, not a difficult procedure, just a lot of work. And as I said before, because there's a lot of work, there's room for error if you're not paying attention. So you can see that if we were going to use 8 segments, right? Our interval is 4. If we're going to use 8 segments, that would be 4 divided by 8. That would mean that each smaller interval is a half. And so then I would have 9 points. -1, -half, 1, half, 1, 1.5, 2, 1, 2.5, 3. Now, is this going to give me a more accurate estimate of the length of that curve? Of course it is. All right? But again, lots of work, but not insurmountable. Okay, now let's look at an example using a trig function. So suppose we have a function 2 times the cosine of theta minus pi over 4. It is extremely important that you are in radian mode for this. Okay, I want you to think about this. Our y-axis is in units, right? Half a unit, 1 whole unit, and so on. If you convert your x-axis to degrees, what you are saying is that the distance from 0 to pi over 2 is 90. Now, that would be okay, but that unit is degrees. If you're using the distance formula and you're squaring degrees, right, change in x squared, and you're squaring y, and this is in units, your units are different. This is degrees, this is units. That basically stay in radians. The distance from 0 to pi over 2, remember pi is 3.14159 and so on. Pi over 2, 1.57. So this distance is 1.57. That's extremely, extremely important. Otherwise, your answer will be a little crazy. So suppose we want to estimate the length of the curve of this function from 0 to pi over 2. Suppose we would also like to use 4 line segments as well. All right. So remember, we want to find out the total length of this interval from 0 to pi over 2. Well, that's pi over 2. Because we're using 4 line segments, we're going to divide this by 4. And that gives us pi over 8. So what that means is the difference between each smaller interval, and again, this is 2 pi over 8, or pi over 4, and this is 3 pi over 8. So the distance, or excuse me, the difference between each of these is pi over 8. Okay? Again, I have 5 points for 4 line segments. Now, as you do this, I want you to be thoughtful about this. In some cases, your function will have symmetry. You do not have to draw the graph. If you are good with your trig graphs, I highly recommend doing it. Otherwise, you cannot assume that there will be symmetry within an interval. By drawing it, I can see there is symmetry. So if I look at this distance, d1, d2, d3, and d4, I can see that this distance, d1, is the same as d4. d2 is the same as d3 because of the symmetry within the interval. That means I really only need to find d1 and d2 and then multiply by 2 to get the whole estimate. Okay? So, let's see. When x is 0, right, y is going to be 2 times the cosine of 0 minus pi over 4. Remember to be in radians, all right? Very important. So, again, we're going to use our calculator. 0 minus pi over 4, and you can see that I am in degree mode. All right, let's change that again. All right, 0 minus pi divided by 4. I'm going to take the cosine of that, and I'm going to multiply it by 2. And in your calculator, you're going to realize that's the square root of 2. Okay, fantastic. All right, now let's get the other points. Okay, again, even though I have 5 points, as we said earlier, we really only need to get D1 and D2. So I really only need to get these 3 points, which I have here. So, using the distance formula, right, D1 is, right, the square root. Again, the difference in my x's is, in this case, will be pi over 8 squared. Plus the difference in our y's, right? Square root of 2 minus 1.8478. Remember, when you're doing this, don't go to 2 decimal places. With trig, at least go to 4. All right? Very important. All right? And when you do this, you're getting approximately 0.585. That's D1. All right? And we can find that D2 is approximately 0.421. And now we just have to make a very nice simple calculation. Our approximation for the length of the curve of this function from 0 to pi over 2, we're going to take the sum of our 2 distances and multiply by 2. And we get approximately 2.012 units. Okay, again, the big thing here, stay in radians. If you use degrees, you're going to get a very strange answer. All right, at least go out to 4 decimal places for trig. Don't round too early so that your final answer will be fairly accurate. All right, I hope that helps. Thanks for watching.